Hey y'all! Today's objective is experimental and theoretical probability. Experimental and theoretical. I know last year you went over experimental and theoretical, so the purpose in 7th grade now is using experimental and theoretical to make a prediction. It's not necessarily just finding the experimental and theoretical, but it's using it to make a prediction. So here are the definitions for theoretical and experimental. Basically, theoretical is what should happen, like it's what should happen. Experimental probability is what actually does happen. It does. So you actually do an experiment and you come up with some data. So for example, if I flipped coins 10 times, if I flipped a coin 10 times, I should get, theoretical probability for me to get heads would be 1/2. That's the theoretical probability, because on a coin you have a head and a tail, so it would be 1 out of 2. Experimental probability, though, if this is what I tallied, it says that it would be 6/10, which would be 3/5. It's a little more than half, and that's the experimental probability because that's what actually did happen. That's what does happen. This is what should happen. Sometimes it'll happen, sometimes it won't, but that's the difference between theoretical and probability. And then you make predictions. All right, so example 1, find the probability. So we have a spinner over here, and I didn't write out all the colors, I just used the colors. So we have blue and green and yellow and orange. So Chris spins it 50 times, so he's doing an experiment, and he lands on green 22 times. So what is the experimental, EXP, experimental probability of green? So green happened 22 out of 50, 22 out of 50. You could reduce it, I guess, and you could get 11 over 25. I just divided them both by 2. That is the experimental probability. Now, how does that compare to the theoretical probability of green? Well, what is the theoretical probability of getting green? Over here, out of the total, I have 3 greens and 2, 4, 6, 8 total. So 3/8 is the theoretical probability of getting green, 3/8. The experimental probability is 22 over 50 or 11 over 25. So how do those compare? And whenever you see compare, you're asking about higher or lower or equal. So how do those compare? Which one's higher, which one's lower, or are they about the same? There's a couple of things you could do. You can type them in your calculator. So let's type in 11 divided by 25, and this is 0.44. Now let's type in 3 divided by 8. This is 0.37. Actually, 0.38. So the experimental probability is a little higher, but they're pretty close. Would you agree? Oh, hey. Okay, it's okay. So 11 out of 25, it's a little less than half, which 3/8 is a little less than half also. So we could say the experimental probability is greater than the theoretical. That's how you compare which one's bigger, which one's smaller, or are they equal. So the experimental probability is a little greater than the theoretical. Make sure you pause it and copy this down. We're going to make some predictions. Re-roll 2 die and take the sum. So let's pretend I have some number cubes, some die, and I'm rolling them 10 times. And every time I roll them, I record the sum of what is what's happened on the roll. So I've rolled them 10 times, and here are my sums. What is the experimental probability of getting a 7? So my experimental probability, how many times did I get a 7? 3 out of 10. Alright, that's my experimental probability, 3/10. Letter B. If we rolled 100 times based on experimental probability, so based on this, how many times would you get 7? So based on my experimental probability, so it would be 3/10, and I want to roll it 100 times. You can set up a proportion, you can solve it, or you can do this mentally in your head if you'd like. But based on my experimental probability, I have to use this 3/10. 100 times goes on the bottom, So if you solved that, it would be 30 times. I would expect to get a 7 based on experimental probability. Doesn't mean it's going to happen, that's just what my prediction. Okay, so C. If we rolled it 50 times based on experimental probability, how many times would you get a 7? So again, I need to use 3/10. This time I have a 50. So 10 times 5 is 50, so 3 times 5 would be 15. So I would expect that to happen 15 times based on my experimental probability. All right, so you try. You roll a 6-sided number cube, which is really just a dice. Dice. You roll a 6-sided number cube 60 times. And here is your data. You rolled a 1 6 times, a 2 15, you rolled a 6 7 times. So I want you to try these questions, press pause, and then when you're ready to hear the answers, press play. Okay, so A, the experimental probability of rolling a 4. So we come right here, 4. That happens 11 times out of 60. 11 times out of 60. If you want to, you can turn it into a decimal by dividing 11 out of 60. Ooh. 0.183 repeating. Yeah. What is the theoretical probability of rolling a 4? If you have a number cube and you just want to know what's the chance that you roll a 4, you have 1 4 out of 6 sides, because there are 6 sides, 1 through 6. And 1 6 as a decimal, 1 6 is 0.16 repeating. So we have 0.18 and 0.16 repeating. How do they compare? Well, they're very close, aren't they? They're very close. And I'd say the experimental is slightly larger. But, they really are very, very, very close. Almost equal. Based on theoretical probability, so now we're using the theoretical probability. If you rolled it 900 times, how many would be 4? So the theoretical probability is 1 6. And we want to roll it 900 times. So you'd set up that proportion. And when you solve that proportion, you would get 150 times you would get a 4 based on theoretical probability. Based on theoretical probability, you would get a 4. Now, if it asks for experimental probability, your answer might be a little different. But based on theoretical probability, you have to use the 1 6. Okay? So example 3. In a school of 300, Wes surveyed 80 students. 44 prefer chocolate ice cream. I like chocolate ice cream. Based on his results, how many in the school prefer chocolate? So this problem doesn't tell you based on theoretical or experimental. You have to figure that out from his results. His results mean experimental, like basically his experiment, his survey. So 44 out of 80 prefer chocolate. But we want to know out of 300. So you set up this proportion. And then you are going to cross multiply and divide, and we get 165. So the question says how many students prefer chocolate. It looks like 165 students would prefer chocolate, and that is a little more than half, which makes sense because 44 is a little more than half of 80. All right, so you try number 4. If you roll a number cube, that's dice, right? You're just rolling one dice. I think dice, or one die, like one die. I guess dice is plural, so one die. You roll one die 600 times. Based on theoretical probability, how many times would you expect to get a 3 or a 6? So the probability of a 3 or a 6. So first you have to do the theoretical probability. Theoretical probability. Then you'd have to do it for 600 times. So what we'll do is we will go over this answer tomorrow. And we will practice making predictions based on experimental probability and theoretical probability. And hopefully we'll have enough time to do experiments. So we'll make a prediction and then we'll do the experiment and we'll see if we're correct. See you tomorrow.